Now we come to the next class of binaries, which we will call as spectrum binaries. As the name suggests, you know that we are measuring light as a function of its frequency or wavelength or energy, because we know by Planck's law that frequency and energy are related. Okay. So here we are looking at how is my photon distributed over the wavelength or frequency. I might use the word frequency or wavelength interchangeably. Okay. Now, all of you understand what a spectrum is, right? If you take the sunlight and pass it through a prism, then you see that that white light is split into different colors, and all these colors correspond to a particular wavelength, right? So this is an example of a continuum spectrum, okay, where you have some light at every wavelength. Now, if it happens that the light that you are receiving, that is reaching you, is obstructed by some medium, and that medium has atoms which have energy levels corresponding to certain discrete energies, then those particular atoms or molecules will absorb the photon at particular discrete wavelengths. And hence, what you will see are absorption spectrum. You have dark lines at particular energy values. Now, at what energy you see the dark line, your absorption spectrum, this depends on the physical property of the atoms, which is determined by the physical environment in which the atoms are residing. So, the strength of the lines and which lines are more populated than the other lines, they are determined by the physical parameter of the environment of these atoms. And hence, we can get an idea of the physical region in which these atoms are existing, where these lines are created. So, depending on the physical parameters, where the most critical parameter is temperature, we can find out the temperature of a particular region from where we see this absorption spectrum. Okay. For example, when it comes to this is an absorption spectrum of the sun. So you can see so many elements are present out here. Okay. In contrast, this you see as the spectrum of Sirius, where certain lines are very, very strong lines and other lines are extremely weak. It's not that these lines do not exist. They exist, but they are extremely weak. And this difference in the spectrum is mainly due to the temperature of the stars. So, if we can measure this spectrum accurately, then we are measuring the temperature of the objects from which these lines are originating. Okay? So now you can understand that the characteristic spectrum is a signature of the temperature of the object which is giving rise to the spectrum. So now, even if you cannot resolve the object from the spectrum, you can derive the physical properties, and that is why spectral study is extremely important and give you maximum amount of information about the physical scenario. Okay, so now let's understand what is a spectrum binary. Let's take a hot star. Okay, and the hot star will have these absorption lines present. Okay, so these are the lines that you will expect from a hot star. From a cool star, you will see these set of lines are present. Now, when you are looking at an object and the object is appearing like a one single object, you are unable to resolve anything beyond one object. But when you take the spectrum, you see a set of lines which is a combination of a hot star and a cool star. Now you know that the two objects have to be separate because one object cannot have such a high temperature and low temperature region. Because then what will happen? You will have transfer of heat. Whenever you have in one object two regions of different temperature, there is a transfer of heat and you will reach a temperature which will be the result of thermal equilibrium. So because of our thermodynamics knowledge, we will know immediately not just thermodynamics knowledge and the knowledge of atomic physics. We know immediately that this kind of a spectrum is not possible from one body. It has to come from two bodies. So even if we are not able to spatially resolve two bodies, just looking at the spectrum, we can infer that we are actually observing two bodies. So they are so close together, they must be a binary star system. And since we are using the spectrum to distinguish the two different bodies, it is known as a spectrum binary. So when it comes to binary star systems, where we recognize the binary companions with their spectrum, this field of work is a very productive field of work even today, and people are using the modern day machine learning technologies to understand the physics of these spectrum binaries and develop better stellar models to understand these systems. If you are interested, maybe you can look at this paper and get into the more detailed understanding of these models which are created to understand this classification of binary stars.